Hi everyone, my name is Yuchendu. Here is my Lab4 circuit. Here's my introduction. We use the principle of conservation of energy to predict circuits containing series and parallel resistors. Also, we use multiple meters to measure the actual values of combination currents and potential differences, and to check ohmic resistors and capacitors. Here are some virtual models of the circuit created in this research. In the first part, we created a simple circuit and showing the parameters for measuring the current flow through the circuit. Importantly, the measured currents are almost identical. When measured in reverse, the measured current is negative because the current enters the emitter from the other end. In the second part, the same simple circuit was used with the voltmeter instead. The result was a measured potential difference of 3 volts and a current of 0 amperes in the battery. This was due to the high internal resistance of the voltmeter, which essentially froze the circuit and prevented the flow of the current. In part 3, the voltmeter was replaced with the wire and the potential difference at different points in the circuit was measured. Unfortunately, the potential differences conform to the rules of the circuit because the sum of the potential differences equal to 0 volts. In part 5, the RC circuit was constructed using the components on the slides. The charging and the discharging times of the capacitors are then measured. For each resistor, the discharge time is almost equal to the capacitor charging time between the two capacitors, while for the 20 ohm resistor, the charge and discharge times are almost twice as long as for the 10 ohm resistors. In part 6, we built a RC circuit with the components shown on the slide. Close the circuit and let the capacitor charge. Then remove the battery, close the circuit again, and let the capacitor discharge. Measure the potential difference in the capacitor every second until 20 seconds. In plotting the graph, the ratio of the bottom is equal to the sum of 0 volts. Another part of the same circuit is reconfigured with the ammeter connected in parallel with a 100 ohm resistor. The resulting current is greater than that of the original circuit because the resulting junction allows more current to bypass the resistor, thus increasing the total current. Finally, devote the initial potential differences by the natural logarithm of the inserted potential difference. The linear slope of the insertion is then used to calculate the RC time cost of the RC circuit, which is equal to about 6 seconds. Now, due to the lack of accuracy of the ammeter and the calculator resistance value in part 6 is larger than the actual resistance value. In addition to the lack of accuracy in the FET simulation, other sources of error included loading errors in the calculation, timing errors in part 6, and failure to consider the resistance of the wires. Thus, if a real circuit was used for this investigation, we would read a slightly lower value of current due to the resistance of the ammeter and the wires and the almost charging in relation to the capacitor and the RC circuits. However, due to the resistance in the wires and the capacitors, a real RC circuit would not charge instantly because the resistance and the current cause the charge to take more time to flow through, thus build up power.